In this video, we're going to be solving the Physics 217 past question for the ECZ exam. Now, question 1 says, figure 1.1 is a full-scale drawing of an aluminium bar. Now, if this is your first time of hitting this channel, please do not forget to hit the subscribe button and click the notification bell for subsequent videos. Now, it says A says calculate the volume of the bar. Now, how do you calculate volume of a cuboid? Now, in order to calculate the volume of a cuboid, the volume it's giving us the length times the breadth times the height. So here, our length is going to be 5 cm, our breadth is going to be, that's the width, it's going to be 2 cm, and our height is going to be what? That's 2 cm. So this is 5 times 2 times 2. Now this is going to give us 20 cm cube. So that's the final answer of the volume of the bar. Now B says what other measurements are needed to determine the density of aluminium? Now, what is density? Density is giving us mass over volume of material. So now the other material needed to determine the density is going to be what? That's called the mass. Okay, so that's our final answer. Now C says when placed on a measuring pan, a reading of 56 grams is obtained. On figure 1.2, draw a pointer to show a reading of 56 grams. Now, if you watch, this point is 0, this is 5, this is 10, this is 15, 20, and so on to 55. Now, 56 is going to be, now if you want to draw your pointer, sorry. Okay, so this is going to be where my pointer, sorry. This is where my pointer will point it. So that's it's 56 grams. So that's 56 grams. Okay. So I says find the density of the aluminium bar. Okay, so density is giving us as mass over volume. Now this is the same thing as our mass is 56 in brackets, this is a G, while our volume is in 20, that's in cm cube. So 56 divided by 20. Okay, so when you reduce 56 over 20, this will give you 2 here is going to give us that's 10, 2 here is going to give us that would be 20. 2 in 5 is going to be 2, 2 in 16 is going to be 8. Okay, 2 can also go, you do 2 here is going to be 5, and 2 here is going to be 14. So if you do 14, 5 into 14, so this is going to be 2 points. 5 times 2, this will be 10, you bring your 4 down. 5 into 4, you cannot go, you put your 0. 5 into 40 is going to be 8. So this is going to be 2.8. So density is this is going to be equal to 2.8 G per cm cube. Final answer. Question 2 says a mango of mass 200 grams drops from a mango tree as shown in the figure 2.1. It takes 1 second to strike the muddy ground and penetrate 4 cm into the ground. Take G to be 10 meters per second square. Okay, now it says from what height did the mango drop? Okay, so now we are trying to calculate the height the mango dropped from. Now notice we were given some certain parameters. Like we're giving the mass of the mango, which is 200 grams. We're giving the time it takes to strike the muddy ground, which is 1 second, and we're giving 4 cm, which was the distance in which it penetrated the ground. Now, in order to solve this, Okay, the first equation we are going to be applying here is going to be V is equal to U. Now, since it's dropping from the top, so it's going to be plus is positive gravity, so this is GT. Okay, now I want you to know that whenever something is dropping from up, U is always equal to 0. So this is V is equal to what? GT. So from here, you can say V will be, now our gravity is 10 times the time, which is 1, which is what? 10 meter per second. Okay, now we know this. We can now use this to now calculate our height. So, which is going to be, our height is going to be V squared is equal to U squared plus 2GH. Now, also note that your U is also what? 0. So, this is V, that's 10 squared is equal to 2 times gravity times height. Therefore, your height is going to be 10 square over 2 times 10, which is going to give us 100 over 20. Now 20 here is into 1, 20 into 100 is going to give us 5. So our height is going to be 5 meters. Okay, so that is exactly the height at which the mango fell from. Okay, now we've established the height the mango fell from. So the next question says, what is the kinetic energy of the mango before it just strikes the ground? Now, you need to recall that formula for our kinetic energy, it's what? Half times mass times velocity squared. Okay, so now our mass was given us, let's check out the value of our mass, that's 200 grams, and our velocity, our V, we got our V as 10. Okay, so if our mass, it's 200 grams, which is equal to 0.2 kg, our V is going to be 10 meter per second. So from here, we can now calculate our kinetic energy. Our kinetic energy, it's going to be half times our mass, which is 0.2, times our velocity, which is 10 square. Okay, so this is going to be half times 0.2 times 10 square is going to give us 100. So 2 into 1 here, 2 into 100, it's going to give us 50. So this is going to be 0.2 times 50. So when you do 0.2 times 50, 50 times 2 is going to give us 100. You bring back your decimal place, so you're going to have 10.0. So our final answer here is going to be 10.0 joules. So that is the kinetic energy of the mango just before it strikes the ground. If you've not hit the subscribe button, please do not forget to hit the subscribe button and click on the notification bell so you can get more videos from us. Stay tuned as we solve more questions.